Okay, so what I'm going to do in this session is a preview of Module 15, Topic 3, Homework 1. I'm just going to do question 1. That's for the homework that's due tonight, and then leave the other homeworks to you. But don't let this substitute for the lecture video on this topic. You need to go back and also watch those because they're more detailed. Here I'm really just sort of doing the homework. Also I did another recording this morning before the regularly scheduled time. I did a review going over Module 15, Homework 2. So let's jump over here to tonight's homework, Module 15, Topic 3, Homework 1, this item here in the workbook. And it's back to this same problem about the Environmental Protection Agency. They have this null hypothesis that the mean car exhaust emissions are 1.45 grams per mile for a sample of 28 cars. And we're testing that against the alternative that the population mean is less than that. And so what I'm going to do is I'm going to start by drawing a picture of this situation. Well, actually, that's okay. I'll do the little calculation first, and then question C is to draw the picture. Okay, so question B is just if you went out and you got a sample, and the sample mean was 1.21 grams per mile. You're thinking, well, that's less than what the EPA said. They said 1.45. So this is evidence that maybe we should reject the 1.45 in favor of the idea that the population mean is less. But the reason why I say maybe is this 1.21, it's only for your little sample of 28 cars. It's not for all the cars. There are millions of them, right? So we don't know for sure. And that's where all this probability comes in. Now, in question B, it's asking me to take the test statistic, and sometimes I'll ask people calculate the test statistic, and they don't know what I'm talking about. Okay, it's the Z. Okay, in this problem, because the population standard deviation is known, the sigma is known, so we're using Z for our test statistic. If we did not know sigma, then we would be using the T statistic instead of the Z statistic. So calculate the test statistic, the Z, in standardized units. So assuming the null hypothesis is true. So we want to take our sample mean and convert it into the test statistic, just convert it into standardized units. And so it's all filled in for you here. You just have to do that in your calculator or using Excel. And where people go wrong occasionally is just with the units of measurement, the grouping. So you need the parentheses. So you group that together, and then you divide. And on the bottom, you have to group that together too. So all these parentheses are needed. But if you put them there, you get negative 3.17 STD units. Okay. Now they're asking us to draw a picture. to draw a picture of the distribution that the sample mean would have if the null hypothesis were true. Okay. So, and it says to label the axes and mark the scale in both the natural and standardized units. I'm going to draw the standardized units first. Just because it's easy to set up the scale that way. You know that the zero's in the middle, and by the time you get back to like -3 STDs, the curve's down to almost 0 at that point. Okay. So let's see. I just kind of... I'm not going to put a scale on the vertical axis. It tells me to label the vertical axis. I'll do that. I was trying to get that centered, but you get the idea. So this is the probability density. It's like percent frequency density. Okay. And this is Z. We'll also have X bar on the same axis. So this is the sample mean efficiency. That's in grams per mile. And this is the Z-score, or the test statistic. Which is the same thing, just standardized units. Okay. Now, if the null hypothesis was true, at 0 STDs would convert to 1.45 grams per mile. And whenever you get a sample of 28 cars, you'll get a point somewhere along the axis here. You know, ours was at 1.21 grams per mile, or way back here at the back at -3.17 STDs. So here's -3.17 right here. Okay. Our sample at Z equals -3.17 STDs. Or positive 1.21 grams per mile. That's this point here, far back at the tail. So you can already see, if the null hypothesis was true, the probability of getting such a small sample mean is really tiny. So out of all the different billions of different ways you could pick your 28 cars, you know, just a very few times you would get one down there if the mean was 1.45. So either we got one of those really unusual cars, okay, or the mean's not 1.45. You see the logic of it. It's just, you know, maybe General Motors manufactured 1 million cars, and you might have 1 or 2 of them back here just by chance, you know. but you're not going to have, or one or two samples might fall down here just by chance, but unless we got one of those, then 1.45 just is not the mean. Okay. So there's our sample. And let's see, I need to mark the scale. So the -1 was, let's see, our standard deviation. Our standard deviation was sigma over square root n. It's this, okay? So it's roughly 0.08 grams per mile. So how many grams per mile is -1 STD? So this would be, let me just do it on a separate piece of paper over here. So if I do 1.45 grams per mile and take away 1 STD, that's minus 0.08 grams per mile roughly. So that's 1.38, let's see, 1.45 minus 0.08. 1.45 minus 0.08 equals 1.37 grams per mile. Okay. Or if I subtract 0.08 again, I get 1.29 grams per mile, and so forth. Okay. We're going the other way. I keep adding, so I'll take 1.45 plus 0.08. Okay. So, on the exam and in this question over here where it says, label the axes, mark the horizontal scale in both natural and standardized units. Here's the standardized, here's the natural. You put the label over here. And so that's how you do those. Okay, so we've done question C. And now we're supposed to calculate the p-value. So, and we need to just keep repeating and clarifying what's the p-value. So, it's the probability that we'd get such an extreme sample mean as we got if the null hypothesis was true. Now, what do I mean by extreme? Well, this is a one-sided, left-sided hypothesis. Alternative. So we're trying to find what's the probability, we'd reject the null hypothesis if the sample mean was far off to the left. So we want to know what's the probability that a sample mean would be so far to the left. As we got. If the null hypothesis was true. Yeah. Okay. And why did I use this less than? Doesn't matter whether you include the equals, you get the same probability either way. But why am I going, it's because of the null hypothesis. I said no, I meant alternative hypothesis. So that's why I need the probability that Z's less than negative 3.17. I've just converted into standardized units. So I can do that using the standard normal distribution. Yeah. And so let's see what we get and fill in the blank. Get the spreadsheet. So what's my p-value? Do norm.s.dist. I'll just click on that cell so I don't round off. I get the cumulative area to the left. And I get 0.07%. Now, so you say to the EPA, I got a sample mean smaller than your 1.45, and they say you just got lucky. And you say, well, if you're right about your hypothesis, I must have got pretty darn lucky. Here's the probability I would have got so lucky if you were right. So I don't think it happened. And they say, okay, since the p-val was less than the alpha was 0.01 or 1%, they agree that that's convincing enough and will reject the null hypothesis that the mean is 1.45 in favor of the alternative that the population means less than 1.45. Population means probably not 1.21, that's just our sample. But getting that sample makes us think it's low probability that the population mean would be 1.45. So there you go. And so we reject the null hypothesis. Ooh, I think I rounded wrong here. That's not good. Let me look back at Excel and see what I did. No, I didn't round wrong. I rounded wrong in the in the workbook over here. So what's the decision? We reject the null hypothesis. So what do we conclude? And I wrote out the answer here in the workbook already because the wording is really important. There is enough evidence to reject the hypothesis that the true mean is 1.45 in favor of the hypothesis that it's less than 1.45. Okay. So as you're going through this first homework, when we come down to the bottom of each one and reach a conclusion, I provide you with the answer. But be sure and read those to understand the logic of it. And then on the final exam, if you have to write one of those, go back and look at, one of these where we either reject or we fail to reject, and use the same kind of language. See, in the one with the Montana residences, with the water consumption, there was not enough evidence to reject the null hypothesis. See, now it's just that there's not enough evidence. We did have some evidence against the null hypothesis. We don't accept the null hypothesis. All we have before us is evidence against it. It's just the evidence is not really strong. And so we don't say we accept it, we just failed to reject it. To be more confident, we're not 90% confident. We might be 85% confident, but we're not 90% confident, so we fail to reject. That's all. And so that's the logical mistake people make. They start to believe, okay, well, I collected some data and I did not reject the null hypothesis, so it must be true. But that doesn't prove anything. If it was a small sample, if you don't have high confidence, then it's not, you haven't proven anything. Okay. All right, so I think that does it for this topic. I'm going to call it a day. And do send email if you're having questions. Okay, bye-bye.